Smart Factory Monitoring System, Emertxe Technologies, Internship on IoT, presented by M. Daniel Abhishek K. Varshit. Contents: Things learned during internship, Introduction to IoT, Project Statement, Project Requirements, Screenshots, Conclusion, Implementation. Things learned during internship, project overview and tools used. Introduction to Smart Factory Monitoring System, understanding industrial IoT and real-time monitoring. Monitoring environmental parameters like temperature and humidity. Tools and platforms, Arduino IDE for coding, PixSimLab for simulation, ThingsBoard for cloud visualization, serial monitoring for debugging. System design and implementation. DHT sensor used for temperature and humidity sensing. Arduino process the sensor data. Code written and compiled in Arduino IDE. Generated .hex file uploaded to PixSimLab. Complete system simulated without hardware. Functionality: reading real-time sensor values. Displaying output using serial monitor. Continuous monitoring through simulation. IoT integration and result. Sensor data sent to ThingsBoard platform, real-time monitoring using cloud dashboard, visualization of temperature and humidity data flow, sensor to Arduino to cloud and to user dashboard. Results and skills. Successfully implemented monitoring system, uh, learned PixSimLab simulation, gained experience in Arduino programming, understood cloud-based monitoring. Problem statement. Industries face difficulty in continuously monitoring environmental parameters like temperature and humidity manually, which can lead to inefficiency, safety issues, and increased labor. Hence, there is a need for an automated system to monitor and display real-time data. Project requirements. Real-time sensor data collections every 5 seconds, automated threshold-based alerting, temperature, vibration, humidity, remote relay or actuator control via ThingsBoard dashboard, historical trend analysis and data reporting, multi-node coordination for emergency scenarios, MQTT telemetry publishing with JSON payload format, components required, hardware required, Arduino Uno, LM35, DHT22, push button, PIR sensor, ETH W5500, LEDs, vibration sensor, switch, relay module. Software required: Arduino IDE to code, PixSimLab for simulation, ThinkBoard, cloud server. Arduino Uno, a microcontroller board based on Atmega 328P, used to read sensor data and control operations, supports digital and analog input or output programmed using Arduino IDE. LM35 temperature sensor measures temperature in Celsius, provides analog voltage output proportional to temperature, high accuracy and easy to interface, use it for temperature monitoring. DH222 temperature and humidity sensor measures both temperature and humidity, provides digital output signal more accurate than DHT11, use it for environmental monitoring. Push button, simple input device, use it for user interaction, works as on or off switch, sends signal to microcontroller when pressed, use it for manual control. PAR sensor detects motion using infrared radiation, use it to sense human movement, outputs digital signal, high or low, used in security and automation systems. ETH-W5500 Ethernet module provides internet connectivity using Ethernet, use it to send data to cloud server, supports TCP or IP communication, enables IoT based monitoring. LEDs, use it for indication and status display, turns on or off based on system output, helps in visual monitoring, low power consumption. Vibration sensor detects vibrations or movements, outputs signal when vibrations occurs, use it for machine monitoring, helps in fault detection. Arduino IDE, use it to write and upload code, supports C or C++ programming, provides compilation and debugging, easy to use interface. PixSimLab, simulation tool for embedded systems, use it to test circuits without hardware, supports Arduino based simulation, helps in debugging and learning. ThingsBoard, cloud platform for IoT application, use it to visualize sensor data, provides real-time dashboards, enables remote monitoring. Conclusion, successfully designed and implemented a smart factory monitoring systems for real-time industrial parameter tracking, achieved accurate sensing of temperature and humidity using integrated sensors and Arduino based processing, implemented and tested the complete system using PixSimLab, eliminating the need for physical hardware, enabled real-time data visualization on the Things board cloud platform, improving monitoring efficiency, demonstrated how IoT can reduce manual effort and enhance reliability in industrial environments, gain hands-on experience in embedded systems, simulation tools, and cloud-based IoT integration, developed a strong understanding of real-time data acquisition, processing, and monitoring systems.
Hello all, now I'm going to explain how we implemented our project. So firstly, hardware is implemented virtually using this PixinLab software. So I have already written the code for this node 1 implementation. So now I'm going to loading the hex file of that node 1 code. So after loading the code into the Arduino Uno, these all sensors gets work. So all the data will be read and it will be sent to the ThingsBoard cloud platform. So here we used LM35, which is a temperature sensor and humidity sensors, and for controlling the machine we have used a push button switch, and this W5500 is used for the Ethernet to for the total whole embedded system, and this potentiometer used for the vibration as used as a vibration sensor, and this VTEM is used to connect the cloud ThingsBoard cloud where we virtually see the data, and these three LEDs indicate, that is red, yellow, green. Green indicates that everything is perfect and yellow shows when there is any warnings, and this red indicates that whether there is any fault in our total system. I will explain how we implemented node 2. So firstly we need to load the node 2 file. So I am loading the hex file of the node 2. So these are the sensors which we used in node 2 implementation, like DHT22 PR sensor, and VTEM is used to connect to the cloud, and LDR sensor where we will be seeing whether there is any dark or not, and this door switch is used whether there is any interrupts in the factory, and this ventilation relay will be saying whether there is any interrupts like related to fire fire. So this ventilation relay will be using the fans. So W5500, which is used to connect to the Ethernet controller, which is used to connect to the whole embedded system, and these two LEDs will indicating the whole system. Like green LED will be indicating that everything is perfect regarding the connection, and yellow LED is indicating the warning if there is any connection error or else any sensor error. All these will be indicating by these LEDs. So this W5500 will connecting the Ethernet connection to hold the embedded system. Till now we have discussed how the data is collected from the sensors. So the collected data is shown in a cloud platform. So regarding that we have chosen a platform called ThingsBoard Cloud. So in this cloud platform the data that is collected from the sensors are displayed in this platform. So regarding our project, we have created two devices called production and warehouse. So we have indicated this with node 1 and node 2 earlier. So here these two statuses of these two nodes are active. Why? Because we have connected these two nodes with the Pixim Lab software, so that here it is showing the active status. Why? Because we have used a connection called uh, MQTT, and there is some network connection. So I have created some desktop dashboards related to production line monitor and warehouse and smart factory. So regarding this production line monitor, the whole dashboard shows that all the readings that are coming from the sensors. Like here we will be seeing the temperature, humidity, and alarms, time series chart, switch control, sensor error, relay status, machine status, and this time series table. So the sensors which we used in production line monitor, the readings can be displayed here. Like in temperature we will be seeing 24 degrees Celsius, and humidity it is 60%. So in time series chart, the data is being recording from past last 30 minutes. So hold we in real time in factories we will be seeing that whole day, throughout the day the data should be stored. So here we will be here seeing that real time data, that is from 30 minutes it is been indicating. And the switch control, here it is we can enable or disable the switch control. And the sensor error showing red light. Why? Because uh, there is no indication of the errors. And relay status is also in off state, and machine status is in on state. So in this time series table, the data of all the sensors and actuators will be displaying from past 30 minutes. So here we will be seeing including the date and time. So everything will be monitored here, so it will be easy for the staff of the factory to so this data that is recorded will be useful for the persons to monitor this all, so it will be easy to handle. And here we will be seeing the temperature, humidity, LM35, all this data is being recorded here. And machine status, relay state, sensor error, vibration, all this being displayed in this time series table. And if there is any error or some critical errors regarding this production line, so in this alarms table it will be displaying, so that the management gets alerted and they will rectify it. Now let us see about warehouse. See, in warehouse also earlier we have discussed some sensors we have included: humidity, temperature, LDR, door status, dark is dark, sensor error, motion, all these being we have seen. So in temperature here 24 degrees Celsius and 60% humidity, and here it is indicating the sensor error is in off state and motion detection is in off state, and door status and dark status is everything is in on state. So we have written all this in the code. And in this time series table we have seen that the data is displayed regarding temperature, humidity, LDR value, motion detection, is dark, sensor error, door open. All this is been displaying here in this time series table from past 30 minutes. So here it will be indicating the data, date and time, everything will be shown in this time series table. So it will be useful for the management to monitor all this data and take the necessary steps. And here in this time series chart also whole data will be displaying in this chart manner, and here it is from taking this data from the last 30 minutes. And now we'll go to smart factory. Here the whole data is displayed, uh, both sensors and actuators. Here we'll be displaying all the data, complete data. So by the end of the day it will be useful for the factory management system to check what data is collected and how it is working, everything like machine or else any errors to be checked. Everything will be useful for the factory management system. So this project helps for the management of the factory. uh, to collect the data and monitor everything.